Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by StrongDM. Manage and secure remote access to any database, any server, on-prem or in the cloud, and environments. They make it easy for DevOps teams to enforce the security and controls InfoSec teams require. So if your engineers need access, you need StrongDM. So what can StrongDM do for your team? First off, more control, less hassle. Grant or revoke access to any database or server in one command. Use your SSO to manage access to every database, every server and environment. Second, total visibility. StrongDM upgrades your audit logs, log every permission change, every query, every SSH, and every RDP command, and know who issued those changes. And of course, faster SOC 2 compliance, easily enforce access controls, and instantly answer auditors' questions. Head to strongdm.com/GoTime to learn more and request a free demo. Again, strongdm.com/GoTime. Welcome to Go Time, a podcast featuring a diverse panel and special guests discussing cloud infrastructure, distributed systems, microservices, Kubernetes, Docker, and also Go. We record live every Tuesday at 3 p.m. Eastern, noon Pacific. Join the community that's live with us in real time during the show in the Go Time FM channel in Gopher Slack. Follow us on Twitter, we're at GoTimeFM. Listen live at changelog.com/live or subscribe at changelog.com/GoTime. And now on to the show.
Hello and welcome to Go Time. I'm Matt Ryer. On today's episode, we're talking about tooling. All those great tools that help us be successful, help us do our job. And we use them, Go tools, all the time, every day. We use them for building, for running code, for testing. We use them for formatting our code, for linting and vetting, and many, many, many more things too. And I think this show will be useful to anybody new to Go that wants to get a sense of the tooling around that we all use. And I'm sure there will also be some golden nuggets for the seasoned Gophers also. And I'm so confident because of who's joining me. I'm joined today by, in no particular order, Jana Dogan. Hello, Jana.
Hello. Hey.
Welcome back to Go Time. How have you been?
Yeah, it's been a while. I've been traveling, I guess.
Yeah. You went to, where did you go?
I was in Marbella, Spain, right? Like the last time we talked, like I was just going for like a conference and then I never came back to the show. I'm so sorry.
That's all right. I can understand if you're off on travels to exotic places for work. It's a tough life. And you told me earlier that everything you do at work is completely confidential. Do you want to just break all the rules and tell us anyway? Or?
Well, kind of like, I'm actually about to switch to a new job. Not a new job, but it's sort of like a new role. And currently I'm still exploring what I'm doing, what I'm supposed to do. And it's confidential, not because it's supposed to be super confidential, but I am not sure about like what I will be focusing on. So I think I will need like a week or something.
That's
just
exciting.
Don't get it personal. It's not about you. It's just, I'm still exploring.
Yeah, no, absolutely. I do take it very personally, but I'll pretend that I don't. Also joining us on today's show, it's only Johnny Borsico. Hello, Johnny.
Hello there.
And speaking of new gigs, you've just started yours, haven't you? Or
recently. Yeah, recently. It's been a couple of weeks. Still onboarding, as they say. Still exciting. Still looking forward to contributing and learning. New gigs are always exciting that way, right? There's that honeymoon period where everything is new and you're learning and you're learning about systems and people and all that good stuff. And then at some point, I'm sure I'm going to cross that threshold. I'm like, what is going on? I need to start fixing things. But so far, everything's going well.
Oh, good. I'm glad to hear it. Yes, it is exciting. It's scary and exciting all at the same time, new jobs. But yeah, no, I wish you all the best. Well, if you don't mind, we'll keep asking you about it on the show because I'm very interested. Like, I think it's useful for other people as well to hear about things that we get up to in our professional lives. So if you don't mind, I'll keep bugging you about that.
Sure thing.
So yeah, let's jump straight in. We're gonna be talking about Go tools today, and I asked on Twitter earlier which of the Go tools are people's favorites and which ones do they like the most. Mine, I'll just kick off. Mine probably has to be Go Fumpt or Go FMT or Go Format, however you say it. You see, it for those that don't know, it formats all the Go code so it looks the same. And all the rules are baked into the tool. So you don't get to choose tabs versus spaces. You don't get to choose where the braces go. You don't really get to choose a great deal about the actual format of your code, which again, I think to some people, when they're used to having tools that allow them to configure all this, they feel like that's a deficiency in Go. But it turns out to be one of Go's superpowers, in my opinion, because what happens is all Go code starts to look the same and starts to look familiar. And I've done it where I've been to a project and found that the code just looks like I wrote it, and I definitely didn't. And I think that's awesome. If you think about pull requests, with white space, sometimes pull requests and having loads of white space makes it really difficult to really see what the crux of the change is. Well, with Go Fumpt, we don't have that problem because it's all formatted nicely. Anyone else? How do you feel about Go Fumpt? How do you pronounce it, by the way? Let's just get that one out of the way.
Go Fumpt, right?
Okay, good.
I mean, that's what I know.
Yeah, that's what I was told.
It's always awkward when like if I'm teaching or something and I say the Fumpt package, for example, which is it's people kind of look at me sideways. I'm like, yeah, I know, just go with it, right? Because if you say FMT or format, God forbid, like gophers are gonna look at you a little weird. I'm like, just go with it.
Yeah, it takes a while for people to, I think, parse it initially, and then they learn it and they take it and they don't question it. So I'm trying to keep it consistent by saying Go Fumpt.
Yeah, same. I mean, I agree. Like, I wouldn't have done that, I don't think, naturally, but I heard about it, and yeah, I do it for consistency too. It's funny because sometimes people will say Golang, because when we use Google and when we search or when we use hashtags, we tend to write Golang, but we never say Golang. So it's a little pro tip for anyone that's new to the Go community. Mm-hmm. When you're talking about the language, just call it Go. Don't say Golang. Mm-hmm. Same with Fumpt.
Yep.
Yeah. So with regards to the Fumpt, well, not Fumpt, but Go Fumpt, I should say. The reason, well, let me step back for a little bit. When I first came across Go Fumpt, I was taken aback, honestly, because I wasn't used to basically tooling, sort of formatting my code to look in like a standardized sort of any sort of way, right? So, I come from programming languages where everybody has their little pet peeves, their little quirks about, I like my braces, on to be lined up together, right? And another person will be like, I like my braces to end at the declaration, and then for the closing bracket or brace to be at the end, or whatever. And so it's like people would have sort of these back and forths around sort of styling, what's more readable versus what's not as readable. And obviously it was all sort of subjective, right? Everybody has their own preferences, their own quirks, and what they're used to and what they're not used to. So, but Go Fumpt sort of threw all of that out the window when I first came across it. And I'll be honest, I mean, for the first month or so, I was like, I don't like everything about what it does. I'm happy with like 90% of it, but I don't like everything about it. But then as time went on, I really began to love the tool and what it does, because the beauty of it, I think you touched on that, is that every basic Go code started looking like I expected it to, right? So basically that cognitive load, that aspect of looking at code and reviewing code, that just went out the window. I didn't have to worry about, okay, is this person's code going to look differently formatted than this other one? Basically, I could just focus on the actual code and what it was doing, as opposed to sort of I'm trying to figure out, parse in my head, okay, this person's quirks are that way and that person's quirks are that way, kind of thing. So it was valuable in that way.
Yeah, there's actually something from Robert Grismer that he used to say. He is the person who is maintaining GoFund and like all the rules and so on. He says that he doesn't agree with like all the styling. He doesn't necessarily agree with GoFund, but it's really good that like some tool is enforcing it, so there's no question. I work for a very large company, and I witnessed it took like 4 years to just tweak one little style guideline change on the Java style guideline. And can you imagine, like, there's all these like hundreds of people with like strong opinions about style, just like wasting 4 years debating on minor style issues. I like the fact that it is like GoFund. There's like this canonical place, and there's no debate. There's like one source of truth type of thing, and everybody has to agree with it, even if the formatting is not always what you would desire.
Yeah. Do you think they would be able to retrospectively fit that into the toolchain? Say that there wasn't GoFund originally and it just came out now. Do you think the community and everyone would rally around it in the same way? Or do you think there's something to be said for the fact that this was there from the very beginning?
I think it's necessary that like initially you create some like, initial culture around, just relying on a tool, because I think it creates like enough people, it creates this community with enough people supporting the idea and understanding why it's valuable. If you try to like inject this type of tools at a later time, the community is already fragmented and there's a lot of excuses to, prefer a personal style because you already, for example, invested in one particular style all across a company, and like there's no way to, just kind of like fix things at a later time. So it's really good that they, came up with a tool initially. At least that's my opinion.
Yeah, I agree with you. I mean, there's a few examples where the foresight or the insight from the team in the original design, I think we really benefit from some of those decisions. And we'll talk about more of them as well. I think the fact that another one of the tools, GoTest, that was there as well from the very beginning. So testing as a concept was it was a first-class concern in Go. And that was, of course, makes sense because we at the time it was being designed, that was kind of how we were building software now. We were writing tests a lot. It was an important part of software engineering. But the fact that they make these decisions, I think, early, just sets a precedent, and yeah, from there I think it pays dividends every day.
Yeah, I think Go is doing a good job in terms of like, identifying 80% of what is essential in software engineering, and I think tooling is kind of also representing those priorities.
Yeah, so thinking beyond GoFund then, if we look at GoLint and also GoVet, does anyone want to have a stab at describing the difference between those two, or describing what they actually do? Cool. Well, yeah. So GoLint is I like it. It essentially looks at your code and does some static analysis and can catch common mistakes and kind of give you warnings about them. And usually, sometimes they're not mistakes, but they're just there's best practices and you can run the lint tools on your code and see if it's got any recommendations for things that you might change. So one example is if you have something in a package that's exported, if it starts with a capital letter, then you should have a comment on that, really. That's the sort of accepted practice. Now, the Go spec doesn't say that, so of course, nothing, it's not a compile error if you don't have a comment there, but GoLint tool will catch it and say, for maximum kind of quality, for the best quality, you should consider putting a comment here. And there are a few rules around how we write comments as well, where we repeat the name as the first word in the comment. And so there's a few little things like that are encoded in the linter, right?
Yeah. There's, initial actually, like we need to mention first, I think there's a difference between Vet and Lint. Vet is, reporting more of like suspicious stuff and, like some patterns that might be just, a misuse of of an API, that it may actually, just kind of like corrupt some memory or whatever. Like think about like the typical example of printf. If, you pass the wrong type of arguments, vet is going to complain about it. So both lint is more about like, I think, style errors, more of like, if you don't, for example, GoDoc, a public API, it's going to complain about that type of problems. So vet became a part of the test, but like not, I think all the things that is reported as a part of vet is genuine. So you can like, there could be like false positives as far as I know. And it also applies to lint as well. So these are not like a part of the compiler because, there's like some reports that is not accurate or something. But it's just generally like, you need to follow, they generally generate like genuine enough reports, and they're really useful.
Yeah, you're right. When it catches, if you use like printf or wrapf, if you use one of those f methods, and then you don't put the correct number of verbs or whatever the arguments in, catching things like that is extremely useful because it's quite hard at a glance to just see those kinds of mistakes. So yeah, I think people should switch on those tools for their code base, at least run them for their code base and see what kinds of things it is actually saying, because you might find you agree with them. The comment one's a good example. I mean, it's quite dogmatic. It just says, okay, it's exported, so it needs a comment. Now, if that method is something like, or if it's a function that says new thing, then it's obvious that's making a new thing, and your comment's probably going to say new thing makes a new thing. So we have a little bit of redundancy, but I think generally speaking, if you do follow the lint tools, and then I find that, the code, again, it starts to look more familiar, and you get all the other benefits of Go Fumpt.
One of the things that I typically do, and which is probably the reason why, for me, like off the top of my head, sort of differentiating between the linting and the vetting was sort of, I was like, I guess I've never really thought about the difference that much, because they're part of my toolchain. So like on my day-to-day, I use VS Code and Vim as sort of my editors of choice. And basically they have the plugins, and the extensions sort of, built in as part of my workflow. So every time I hit save, right, these tools are running, right? And I'm getting different, basically markers at different spots from different tools, right? So there's another popular open source project out there, I think it's called the Go Metalinter, which includes a bunch of those kinds of tools as well. You can configure, you can turn some off and others on and whatnot. But these tools together, they give you sort of a one set of outputs that you can basically go through and figure out, oh yeah, I missed, I used the wrong verb here. I'm supposed to use a integer. I'm using a string instead, right? The things that the linter and vet would sort of find for you, and if you ran them sort of individually, but because they're part of my toolchain, that basically I just look at the view at the bottom of my editor and get a list of things that I go and fix. So I've sort of almost basically, I don't care, I should say, which tool is giving me what, unless I really need to work with a specific tool. But I kind of, it's part of my workflow. It's just part of my editor. And every time I hit save, formatting gets done. Go imports does its thing. Whatever I've referenced in my code that is not imported, it brings that in automatically. All these things sort of happen. The tooling sort of makes it easy to sort of just focus on writing the code and not worry so much about having to run individual tools one at a time, kind of thing.
Yeah, it's a good point that actually making it a part of the editing experience is really useful. Like, especially vet is reporting a lot of useful stuff like, hey, this is unreachable, or you're passing the wrong, you're passing, for example, unmarshal a non-pointer and like stuff like that. Like, it's so hard sometimes by just when you're typing and when you're just like coding, but like tool is really helping you to do the right thing as you are programming.
Yeah, I extend that to running tests as well. I tend to write unit tests which run very quickly, and then you can run those every time you save the package. Usually, if they start getting too slow, then of course you have to have a different strategy. But certainly in the beginning, if it's unit tests that just run very quickly, and the build time in Go is still phenomenal. We always kind of forget about it until you have to go and build a different code base. Then you appreciate it again. And Johnny, by the way, the metalinter now apparently is called Golang CI-lint. So if you want to install that into VS Code, it's Golang CI-lint. That's the new name of that. Yeah, but you're right. It's the meta linter. It runs a range of other linters and kind of gives you that one view of it. And they integrate brilliantly into the IDEs as well. So that's the other thing, like you say, you can run it on save, but even if you don't, you can still usually integrate it into the IDE in some way that just makes it part of your routine. Because, anytime you can get that live feedback from the code, that's valuable, because usually as you're working, you learn too. And that's a great way to learn things as you're writing code, and to see a linter saying, oh, this is unreachable now, or that thing's over there now. And if it's tests too, then these tests are broken over here that you didn't expect. And you just get that feedback from the code, which is so useful when you're working.
And you shouldn't have to wait until basically, if you have CI, continuous integration, and you shouldn't have to wait until the code reaches that remote server where all these tools are run for you to get that feedback. It's much easier, much faster, right? Like you're saying, that feedback loop is much tighter when it's part of your tooling. So there's some things you can do locally, right, to make sure your code is functed, make sure it's vetted, it's linted, and all that good stuff. And then when it goes up for review for PR, Circle, whatever CI tool you're using, Travis, Circle, whatever, there's dozens of them these days. So you can sort of, they give it a blessing, and then now people can just focus on what does the code do, right? They don't have to tell you, hey, you forgot to, run Go front on it or something like that, right? So you take advantage of these tools locally. They're very good tools. So I wholeheartedly encourage folks to sort of make them part of your development workflow.
Yeah, one of the, I think, best parts is like they are really fast also. It's a part of the editing experience because they are fast. It's just, I'm coming from like background where, I use a lot of Java tools. And it's, not like as, I think, smooth the experience. We used to have like similar static tools, but it was not as smooth as all these Go tools. So nobody is making it optional because it doesn't really, make the editing experience more challenging because they are fast and they are useful.
This episode is brought to you by DigitalOcean. DigitalOcean makes it super simple to launch a Kubernetes cluster in minutes. The DigitalOcean Kubernetes platform empowers developers to launch their containerized applications into a managed, production-ready cluster without having to maintain or configure the underlying infrastructure. They seamlessly integrate everything with the rest of the DigitalOcean stack, including load balancers, firewalls, object storage spaces, and block storage volumes. They even have built-in support for public and private image registries like Docker Hub and Quay.io. Developers can now run and scale container-based workloads with ease with the DigitalOcean platform. Learn more, get started for free with a $50 credit at do.co/changelog. Again, do.co/changelog.
We mentioned GoTest. That's another tool that we use a lot. Anyone that's not used it, if you write test codes in your Go programs, and you do that usually by naming the file with _test.go at the end, and then you run GoTest, it will look through all those test files and it will actually run all the test code for you. And that's really how, you can, if you do TDD, you know that your code is fulfilling its promises, it's doing what you said it was going to do. There's also another little feature in the test tool which I think gets overlooked a little bit, and it's the race detector. So when you're writing concurrent code, it's possible for you to break the rules and sort of try and read and write from the same data at the same time. And if you try and do something like that, that's illegal and it will crash the program. But of course, it's very difficult to see that sometimes if you've written the concurrent code, and certainly difficult to write tests for it, because sometimes it might just not happen just because of the way that things get scheduled. But there is a race flag which you can pass into Go test, which it's a bit slower, but it does some additional checks, and you can catch those potential deadlocks early, which is kind of cool.
Yeah, and it's the tooling is also a part of the standard tooling. It's not just a test, but it's a really good addition that like TSAN detector is also a part of the tests, because we all have this workflow of not merging things if the tests are not passing. So you would ideally want to enable the race detector as a part of your CI. And it's amazing, but there's like one thing I think we should mention, that your tests should cover concrete cases. So the detector can detect them. If you don't represent those like concrete situations, the detector won't be able to detect them. But it's amazing because it's just like so on point, and it's easy, and it's a part of the standard tools. So you don't have to figure out like all these additional extra tools or whatever in order to get the benefits.
Yeah. Now it's worth saying that the race detector will, if it reports that there's a violation, then that is a violation, but it doesn't necessarily catch everything. Isn't that true?
Yeah.
Okay, but still, I mean, it's still. To be honest, I've never seen a race condition get through after testing it with.
Because you are actually good in terms of you care about your tests, so you represent all the cases probably. I've seen a lot of times people are just not creating those situations where concurrency is a problem. They have all these super micro tests, so they don't really capture it. And I think it's really important to tell that your tests should represent those cases so the race detector can detect them.
Yeah, okay. That's a really good point. Well, with TDD, you tend to get good coverage, even though I don't. Covering, by the way, code coverage is also another part of the tooling that we just get for free, which is awesome. But yeah, I never try and shoot for 100% code coverage or anything, but naturally it's quite high with TDD, and I suppose naturally you'll also cover a lot of those cases that you talked about as well. I like Go Run as well. Go Run is we don't tend to have much magic in Go, but Go Run is probably the magic tool because it actually secretly does a build and then executes. It does a few steps behind the scenes, but it's great if you're just learning to code or you just want to write a little script quickly and just execute a program. You can use Go Run and you pass in the name of the file or files, and it just runs it. I mean, it builds it to a temporary directory, and I think it gets deleted afterwards, although I'm not sure. But yeah, I think that also is such a nice thing to be able to just quickly see results and see feedback from what you're doing. And Go Run is another example of that.
Yeah, I think people use Go Run for their first Hello World program. It sometimes becomes complicated, so then they have this habit of using Go Run. Go Run, I think before GoPad was a little bit more difficult to rely on because it was some sort of it was able to work outside of GoPad. So the behavior of Go Build and Go Run was not quite the same. So it's just kind of people have been advocating to always rely on Go Build or install rather than Go Run. But I think it's just really nice for a Hello World, or if you have a script type of thing that you just Go Run. It's really useful.
Right. The Go Run, I think, you were right, Matt, when you're saying basically it from my understanding is that it does the same thing as Go Build. It's just the difference being that, okay, once a program is run, it just discards that temporary artifact. At least that's the high level of what I think it does. One thing is worth mentioning is also you can run it with I believe it is you can run with a dash race as well. That way, if there's any sort of race conditions in the code, it'll actually, when the program fails, if it panics, then you'll actually get some information around where that sort of a race condition occurred as well.
I didn't know that. That's brilliant.
Yeah, I think race is supported in like test, build, run, like general all across the tools.
But it adds overhead, doesn't it, and slows down your program and things. It's not something you would just always switch on.
Yeah, that's why I think it's useful to just make it an optional thing for tests. But apart from that, like you don't want to have the race detector always on.
Yeah,
I've had mixed results depending on the size of the code base, obviously. But these days I work on a lot of small code bases, like work a lot with microservices, that kind of thing. So these code bases tend to be somewhat small, relatively speaking. So I by default, whenever the default make command, right, I use make. So whenever I run make, the default is basically to just run it with the dash race flag, run the test with the dash race flag. I haven't noticed significant slowdown in that, but again, obviously your mileage is going to vary depending on the size of your project and how many things you got going on.
There was a benchmark about this, and I think it was kind of like memory usage is again like 5 times, larger if you have the race detector on. And I think execution time wise, there was some reports, but it's really dependent on the use case, as you say. So it's kind of like adding some overhead, which could be, I think, 2 to 20x or something, if I can, remember the numbers correctly. There's a really good blog post actually, or an article on the golang.org about the race detector. And there must be some numbers over there.
Yeah, cool. Okay. Well, so I was thinking as well about GoGet. GoGet's another one of the tools which I think, obviously things have changed a lot, especially in the module space. But I've got to say, when I was first using Go, to just be able to install packages by saying GoGet and then the package name, and then for that package name also to be the import path and to be the URL of where that package lives, I found that to be such an elegant thing that it was very easy to install things. I mean, this is in a GoPath world where everything just gets put into one place. But GoGet just really made that very, very easy. How do you feel about GoGet versus the new module tools? Because working with modules is a little bit more complicated.
So I'll punt the modules to JVD and let her tackle that. But I can tell you that when using GoGet, especially when I'm teaching, being able to say, look, we're gonna import this package. Before we can actually import this package and use it in our code, we need to go get it, right? So I'd literally say, okay, go get, and then basically I'd find the name of the package, a fully qualified path, basically with GitHub.com, whatever, or whatever wherever the public repository is, and then basically I'd get this blank stare from the students. They'd be like, okay, what just happened? And then it dawned on me that, okay, if I literally copied, right, that path, go into the browser and paste it into your URL bar and navigate to that repository, immediately they were like, oh, okay, I see what this is, right? You are literally pulling this code that lives at this very path, right? You're putting on the command line. You are pulling it down. Now I can actually see and read that code in my browser and see what it is I'm actually pulling down, right? So the whole thing about pulling down the package, it goes in your Go path, none of that stuff makes sense, right, for them. But the moment that I can actually go into a browser and put that very path in, it sort of clicked, right? Now they understood the value of GoGet, and it didn't quite, it didn't matter really much where it was being put in the Go path. It just the fact that they knew how to get it, they knew how to go, where to go and see whatever was being pulled was almost magical for them.
Funny, because it's no magic, and it's almost the fact that it's so obvious, i.e. that's the URL, go and look at it, you know what a URL is. I think that's great, and that the little story you just told then makes total sense. I mean, if I use some NPM stuff for a project, I install a few things and I look in that node modules folder. There's 16 million folders in there. And yeah, and I don't know where they've come from. It's kind of hidden. It is magic. Whereas it's just, that thing of being very simple and clear, even if you sacrifice some features for that, I always think has such a positive kind of dividend that it keeps paying again and again later.
I think we need to make an episode on Go mod, but I think I agree that like Go Get is a really good, initial experience. And one thing I like about it is if you're Go getting a main package, it installs it, puts in your Go Pat bin directory.
Yeah.
So it's just like a good way to distribute tools as well. Before I think Go, I was just publishing binaries and like making sure that like I have the right version all across. The versioning still is a problem with GoGet, but like I think it's an okay sacrifice.
Yeah. Okay. What I'm gonna do is just keep moving on to different Go tools because I'm already learning things about these as well. And the other one with Go Build, which I love, is the fact that we can do cross compilation. Now this has been around from I think the beginning. Essentially, for those that don't know, you can choose the target architecture, the target machine to build your Go code for. That's very useful if you're using Docker because you can do like on a Mac, you can do the build for Docker, and then you've got the binary, the Linux binary that you can then put into the Docker image, or you can of course put the code into Docker and build it in there in that environment. But how's your experience with cross compilation so far?
I think it was magic. Like when I first saw, they were typing Go, actually it's pronounced Goose, and Windows and Go Build, and like you get a Windows binary. It was like, whoa, right? Like, it was fascinating, and I usually generate binaries for Linux. So it was like I kept, working on my Mac without any worry or anything. It was so awesome.
Yeah. Have you used it, Johnny?
Absolutely. One of my first jobs using Go full time, my responsibility was basically to have a sort of multi-platform build process. So basically, I relied on Goose and Gorch quite a bit. And for those of you who don't know what Gorch is, basically that's the companion to Goose, GOARCH for Go architecture. So using Goose and Gorch were sort of bread and butter to having that work done and basically being able to push out binaries for all kinds of different platforms. And I mean, there are a ton of them that Go supports out of the box for ARM processors, and I mean, there's the sheer combination you can have. I've lost track of basically how all the different variations you can push out, but it's really was a godsend. I mean, there's no way I would have been able to sort of get that job done without these things being in there.
I think it's also awesome that like I was doing a lot of development for ARM and for a Raspberry Pi, for example, the processor on a typical Raspberry Pi is just going to be not comparable to my laptop. So I would just build things on my laptop because it's going to be faster, and then I will push it to the Raspberry Pi because it's just so much easier to do cross compilation, and it's just like maybe like 10 times faster or something.
Wow. And so how does it actually work? Because obviously the compiler is doing a few steps, and then ultimately it then creates a binary that's made up of from the machine code, isn't it? Is it just that the machine code is generated differently depending on the architecture?
Yeah, they know what to generate for each architecture, so they just basically take the input and they know what to map it, and then they generate the output based on the operating system and the architecture.
Mm. And that must have been possible because of the way that they built the tool system. Do you think it was deliberate that they wanted to be able to build to any target architecture, or do you feel like they just realized they could after because they'd just built it and designed it in a simple way?
I don't think you stumble on something like this by accident. I think if I had to guess, I'd say this was by design. is considering that the creators of the language basically basically they were building for Google, right? So I imagine that at some point they need to be able to run binaries on different platforms with different CPU architectures and 32-bit versus 64-bit and all that good stuff. So I imagine this must have been sort of a part of the plan, part of the design. This seems way too complicated and way too powerful a feature to have just come across, to have fallen out of the build system.
Mm.
There's also I think simplified the process, but there's this intermediate assembly. So the compiler first translates everything to that intermediate assembly, and from that point on, they are being compiled to the architecture specific machine code instructions. Sorry. So it's actually the internals of compilers this two-step thing, and this is a really typical way the compilers work. They're just converting everything into an intermediate language. And that from that intermediate language, you can just basically target whatever architecture you want to target.
Mm. And of course, you can have build tags as well. Does anyone want to describe build tags?
Yeah, build tags are this providing conditional compilation, and you can create different rules. For example, you can have constraints to say, only use this file for Linux builds, or you can say, I just want only ARM builds to have this file included in the build. There are many different rules provided by the toolchain. Go version is one of them. Arbitrary custom build tags is one of them. So it kind of gives you this possibility to switch to different implementations depending on the Go version, depending on the operating system or architecture, or some custom build tags.
Yeah, I've used those successfully when it comes to testing. Sometimes if there are long-running tests or if there are integration tests that require a different dependency to be running or something, I use a build tag in our test files, and that's quite an easy way to choose a subset of things to run. And it's just a special comment that goes at the top of the file, isn't it?
Yeah, it's just I think it must be on, it's on the top of the file. There's a particular place. But that's it. And it's really readable. I think my only complaint about these rules, about the build constraints is it's just really hard to sometimes just, have multiple rules represented. It becomes really hard to parse. If you want to have more complex rules, hey, just include this file on Linux, Darwin and blah, blah, but not on this particular thing. On top of that, not for this custom build tag. I think expressing those complicated, more complex type of constraints is a little bit hard. But otherwise, I think it's just pretty straightforward. And I use build tags all the time.
This episode is brought to you by GoCD. With native integrations for Kubernetes and a Helm chart to quickly get started, GoCD is an easy choice for cloud-native teams. With GoCD running on Kubernetes, you define your build workflow and let GoCD provision and scale build infrastructure on the fly for you. GoCD installs as a Kubernetes native application, which allows for ease of operations, easily upgrade and maintain GoCD using Helm, scale your build infrastructure elastically with a new Elastic agent that uses Kubernetes conventions to dynamically scale GoCD agents. GoCD also has first-class integration with Docker registries, easily compose, track, and visualize deployments on Kubernetes. Learn more and get started at gocd.org/Kubernetes. Again, gocd.org/Kubernetes.
Okay, well, I want to also mention a couple of tools from the community as well, because remember, we are using Go tools all the time, but we can write tools as well. And some people have contributed, I think Go Imports was a Brad Fitzpatrick project that was his own kind of idea that he just did on his own, and it essentially wraps Go Fumpt, so you get all the formatting, but it also resolves imports for you. And you can do these things too with your own tools. And some of the tooling as well doesn't have to be Go tooling running on our machine. Matt Holt has a great JSON to Go service. If you Google JSON to Go, you basically paste in a JSON blob and then it generates the Go structures for that JSON blob. Extremely useful, especially if you're going to consume an API and you need all of the data and you just don't want to sit and type out all the field names. So that's a very useful one, and that's a hosted website, so you can go to that. Any other community? Are there any other community tools that we like?
I personally like the Go report card website, which well, I guess it's less of a local tool, but something that can basically evaluate sort of how close to the idioms, right, of the Go community your code is being kept at. I think it might even incorporate some of the tools we've mentioned before, the linter, the vetting, and it includes some other things like cyclomatic complexity analysis, and has a bunch of other nice sort of bits it adds in there as well. And it, sort of based on these things, it gives your repository a grade, right? I think on a scale of A through F or something like that. So I find that useful. So especially when I'm evaluating a repository, a package, third-party package, to determine whether I'm going to use it or not. If it has a score, I will look at that. If it's anything other than an A, then I'm going to take a closer look, right? I'm going to be a little bit more hesitant with sort of bringing it in, because I'm like, okay, well, what best practices, what idioms are you not following, right? So I'll take a look at that, and sometimes I may just sort of see what's happening and maybe replicate it locally without having to bring the package if I don't like the score, so to speak. So it's kind of it's sort of another data point, right, so to speak, to help you sort of evaluate the quality, I should say, of a repository. But yeah, it's one of the things I like to see as well.
The same for GoDoc. GoDoc is a tool you can run locally, but we have also the godoc.org hosted service, which lets us view documentation for any open source project. And so, yeah, I think that's also nice. It's a nice way to provide that capability, because it makes sense. You want to share just a link. And the nice thing is for GoDoc, it's just godoc.org/ I think maybe pkg/ then the import path. So again, you're still referring to that import path when we see it.
I personally use a lot of tools from Dominic Honeff. Like, he has this Go tools repo, static check tool, which contains a lot of style check, a lot of linting type of features that GoLint doesn't support. And it's there are some cases sometimes there's a controversial style topic. It's not possible to merge it into the official tool, so people would just go and put it in the Go static tool. So it's a really useful tool to take a look. In terms of static tools like that, I just rely on static check more than GoLint.
Yeah, and Fatih Arslan, he made a service which I think is called Fixime, which is it's a GitHub integration, as I understand it, and it analyzes. It does a bit like the Go report card, but it actually creates PRs with changes in it. So it actually does it's sort of proactive, like you've got another member on your team that cares only, like the pedant who just cares about all the style rules and all that. And that's a project I think it's worth checking out. It's called it's Fixme. It's spelled Fixmie. So have a look for that one too. It's a similar kind of idea to the Go report card, but more tightly integrated into GitHub. Has anyone here written any kind of tooling, static analysis or otherwise?
I only wrote some tools to generate some stuff from an interface. These are also some static tools. One common case is generating implementations of interfaces, and there's a lot of boilerplate. So I wrote a tool that kind of takes the interface and creates the concrete implementation, and then you just go and fill the implementation fill the methods.
And did you use the AST stuff and the parser and things to build them?
Yeah, I used whatever was in the standard library. It was not that hard. It was not that good looking either, but it was possible to get it done in 100 lines or something.
Yeah. So, okay, cool. Well, I think we should also spend some time talking about some of the performance tools as well. That we just get for free. There are some great talks on YouTube. It's quite an interesting subject, and it's talked about quite a lot from different angles. But perhaps Jana, you could tell us a little bit about. Did I see you do a talk about the performance tools?
It might be possible because I worked on some of the dynamic tools when I was working on Go, so it was part of my full-time job. Mm-hmm. And I generally have been, working in this area for a while. So it's possible that you have seen me giving a talk. But I can't remember because I'm giving too many talks nowadays.
I thought it was all confidential what you work on.
It's not. So the confidential stuff is different.
What's that?
None of my performance tools. It's more about computing, products. And,
right.
We'll figure out in a couple of weeks.
I'm just trying to be like one of those journalists, hard-hitting journalists that tries to get out the information that you don't want to say. But if they're too polite, you just say, I'm not going to talk about it. And I go, oh, okay, bye.
The problem is I really don't know. I know generally what I'm going to be working on, but I don't know the specifics, and I'm a really precise person, I think.
Yeah.
I don't want to give any impressions that I'm going to work on something that I'm not going to, because people will be upset.
Yeah, it's absolutely fair.
Just joking.
Yes. But Jana, could you tell us a bit about some of these tools though, and what they're for anyone that doesn't know about them? Yeah.
I think generally speaking, let's go beyond the performance tools. There are a lot of dynamic tools in Go, and they are a part of the standard tooling. Some of them are related to performance. Some of them are more related to debugging type of stuff. The typical, we can talk about, for example, performance initially, and the Go came around. When it first came around, it came around with some of those dynamic tools because we went to the SRE team, and SRE team at Google is just really specific about what they want to put in production. So they want to have enough visibility into things, and some of these were related to performance. They want to be able to get the profiles. They want to get some runtime traces because they specifically want to be able to understand when there is something going wrong, and they want to be able to pinpoint to those. So pprof support was baked into Go since the early times because of that requirement. For example, it provides you some profiles. You can also add your custom profiles, which is a useful topic. But it provides the CPU profile, memory profile, Go routines, and thread profile, and mutex contention profile, and it was really crucial, to have a language mature enough to put in production, because that's basically, most of people think that performance is about development time, but it's also important in production time. On top of pprof support, there is good benchmarking support baked into Go test. So benchmarking is a first-class citizen in Go, which is not really, quite the same situation in other languages. And I think it kind of creates this culture where you care about, benchmarking stuff, right? I don't know what is your opinion on this, but I've seen, lots of different communities have different opinions about benchmarking just because of the tooling, or, it's really easy to write benchmarks or not. What do you think about it?
Well, I've seen it used perfectly, and I've also seen it used incorrectly. I've seen an example where the benchmark, just because of a slight issue with the way it was written, it was reporting completely incorrect results. So so I think but if it's used in the right way, because if you depends on what you're testing, I suppose. If you're going to be testing something and you're making HTTP requests, for example, there's so much variation anyway in HTTP, you're not really going to be getting any meaningful information. But if you've got two little algorithms and you want to know which one's better at certain tasks and stuff, then yeah, it's great. And I agree with you, Jan. I love the fact that it's baked straight into the language, and you just have to write a function that starts with func benchmark name, take in the special variable, and as long as you get the for loop inside it in the right place, and also think about setup and teardown work and where that's happening, then yeah, it's a great way to really just find out which is better, because sometimes it'd be really surprising. In fact, I think it would make a great talk if someone out there wants to do it, or a presentation of like, here's some code, which one's the fastest, and have people kind of guess. And sometimes I find the results to be very surprising.
Yeah, I think benchmark in general is a discipline that, takes a lot of time to kind of like learn, and what are the, the other factors that actually improve, impacts the performance. So I agree with you that like I've seen a lot of like wrong benchmarks, and people are like super strongly opinionated that it's actually an optimization, but it's actually like one specific thing that improves the performance, maybe like for one specific case or something. And I think you need to have a really good understanding of the runtime and everything around the language in order to write good benchmarks as well as like interpret the results correctly. So it's a really tough game. That's true.
Would you say that when it comes to benchmarking and performance optimization, like I try very, very hard not to sort of jump to that sort of right away. I'll try to solve a problem first and then try to optimize, right? So basically preventing premature optimization. And these tools make it, because they're part of the standard tool chain, they make it very easy to just, start using them like right then and there. So basically start leveraging them right away. And there was a time, maybe we're still in that time, where it seems like there was a new sort of HTTP muxer or router coming out every couple of weeks, and they were all like, "Oh, benchmark compared to these other things. This one is zero allocation and is 0.05% faster than the other one." So it was, I kind of found it silly a little bit because of all that sort of going on, and I was like, okay, we're kind of missing the point here a little bit. But yeah, I mean, it's having that tool. I think it's great, and like you, I don't think I've seen that basically that kind of capability sort of built in, part of the language from the start. So I tend to sort of I'm very careful with that, because it's too easy to create a culture within an engineering team of okay, before I can even ship this thing, I have to make sure it's like super optimized and all that. We're putting kind of the cart before the horse a little bit there. It's too easy to do that. So I tend to shy away from that stuff. I sort of bring it in when I need to.
I completely agree. I think, optimizations in development time is kind of like fabricated problems. Like, I mean, you realize what needs to be optimized in production, right? Like,
right.
For example, what we do is continuous profiling, which is we keep collecting some profiles from the production binaries, and we sort of like have an understanding of like, within this project, what are some of the hot calls and what is like some of the, stuff that is in the critical path, like, and what critical paths are like more often being called, and like, what happens if I just optimize this function, or like, what is the, actual cost of this particular function in the, if you think about the whole system and, depending on the usage and whatever. So I think it just really makes more sense to start thinking about these cases in production, and like by looking at the data, you just go back to the development environment and like try to optimize those things and, keep using these tools. One of the nice things about Go profiling, the actual pprof, is like it's a really low overhead type of profiling thing, and you can enable it in production. So you can, just keep, getting profiles from production without impacting the critical paths so crazily, but there's an overhead. But there are some strategies. If you have multiple replicas of a web server, for example, you can enable production maybe for like 1 minute or 5 minutes on one replica, and it's just like sort of like depending on how much latency you will experience, it's sometimes doable, and that's what we do it. That's how, what we do, and just try to optimize based on the usage and, what is the critical usage and like what are some of the hot paths. Like identifying those hot paths is also very important before jumping into any, optimizations.
Right. Having a problem before you solve it.
Yeah. Yeah.
So, Jana, when you say you do continuous profiling, when you deploy services, do you have pprof already enabled in there and you just switch it on, or?
Yeah, think about like this. So all the Power4 pprof tools, pprof can be tweakable. Like it's dynamically you can turn it on dynamically and you can turn it off. So what we do is basically turn it on for like several minutes, collect the data, just get the data, and just parse it, store it, and then we aggregate all that data. And we have this like daily, weekly, whatever reports, and you can take a look at like, oh, this service, particularly this handler, is often used, and all these like particular functions are, it is accounting for the like most CPU time or memory or whatever, and you can just go and like dig and like optimize those particular places. I wish that Go had like some tools around maybe supporting this type of like more continuous integration, continuous profiling features. It's possible to write a tool kind of aggregates, multiple pprof files. Maybe it could be possible to write like a library that automatically, just turns it once a while, reports to some like central service, and then, turns it off and so on. I think there's like some we can do much better in this field. It's just kind of like up to the user right now to plan and, design and just, do this type of things. But like, that's basically what we do. I wrote on this topic for a while, and it's just really like some companies are aware of these methodologies and some companies are not. And like, it would be so nice if community was, producing more best practices as well as more tooling around this.
Well, there we go. There's the call gone out. Anyone who's looking for a new open source project or something to hack on, what a great problem. Could you build something that samples running Go code and, periodically at some schedule and collects the results up? Would be extremely useful and really fun probably as well.
Yeah, it's like a lot of fun once you start to see, like, for example, a large company, aggregating all the profiling data. So you can see like, oh, the companies, for example, you can actually improve your bill on your cloud provider. You can say that like lots of the calls are actually like dependent on this one function. And, if you optimize it, we can actually cut the billing like by 10% or something, right? Like it's actually pretty useful once you start to do this systematically everywhere.
Well, I love the message of wait till you've got something running and then look at optimizing it. I think in some cases you can shortcut it, but generally speaking, yeah, that advice is sound. And the idea of being able to profile running production systems and to understand them better, I think is a great goal to have. And what a great use of the tools that we have as part of our ecosystem. Well, on that bombshell, I think that's it. I think we've reached the end of the hour, and so the end of this episode. Thank you very much, Johnny and Jana. It's been awesome. How have you liked it?
I can talk about this topic for hours, and I think this was awesome. But we should keep talking about tools, I think.
Yeah, absolutely. Well, there's lots more to discuss, and I might even see if we can bring in some people from the community that have built some of the tools that we're using today. One other little bit of info that I think is quite interesting. The only actual contribution I personally made to the Go project was to remove something from GoLint. So one time, GoLint got a bit easier to satisfy, thanks to me. You're welcome.
Yay!
I delete code. I love it. Well, yeah, that's it. Thank you so much. We'll see you next time on Go Time.
All right, thank you for tuning into this week's episode of Go Time. If you're not yet, hang with us and go for Slack. We have a channel called Go Time FM. Look it up, you'll find us. Hang with us during the live shows, connect with other members of the community, share stories, share code, share coffee recipes, whatever. It's a lot of fun. Also, we have discussions at changelog.com on every episode. Head to changelog.com/GoTime, find this episode, and discuss it with the community. Also, thanks to Fastly, our bandwidth partner, Rollbar for helping us move fast and fix things, and Linode for hosting the Changelog platform. Our music is produced by the mysterious Breakmaster Cylinder. And if you want to hear more awesome podcasts like this, subscribe to our master feed. It's one feed to rule them all, plus some extras that only hit the master feed. Head to changelog.com/master or search for Changelog Master in your podcast client. You'll find us. Thanks for tuning in. We'll see you next week.